Alright, in the previous video lesson we learned about scalar and vector quantities. In this one we are going to specifically learn about distance and displacement. Okay, we will learn the definitions of each of them, key differences, and solve problems to compare distance and displacement. To begin with the definition, let me give you an example. Let's say from place A to B, you're taking a zigzag path to cover the distance. Let's say you covered 25 kilometers of distance. Okay, so 25 kilometers is just a value. It does not give you any direction, so it's distance. So distance of 25 kilometers in this zigzag path. But if you specify that from A to B, you're covering this straight line path, the shortest distance between A and B, let's say is 15 kilometers towards B, this is displacement. Okay, so from A to B, the shortest path that you have covered, displacement. Okay, so the total path covered by an object is the distance, and the straight line from the starting to the ending point is the displacement. In other words, we can say displacement is the shortest path between any 2 points. Okay, to give you another example, let's say you walk around a square park. This is the square park. You start from this position, you go all the way and come to the same position. Let's say you covered 400 meters of distance. Okay, 400 meters of distance around this square park. Okay, but when you talk about displacement, your displacement is 0 meter because your starting and ending position are the same. All right, let's have a look at some key differences between distance and displacement. Okay, many a time in the exam you'll be asked to write the differences between distance and displacement. In that case, you'll have to write the definition and all of these key points. Let's say symbol of distance is D, displacement symbol is S. Okay, symbol is the short form, so you'll write the short form of distance, short form of displacement. SI unit, the standard unit of distance is meter, displacement is also meter. Okay, unit symbol, the short form is M. In this case, this is also M. Okay, as we learned in the previous slide, distance is a scalar quantity because it only has value, and displacement is a vector quantity because it has value and direction. Okay. Equation is distance is equal to speed multiplied by time, d equals to vt. So from this one equation you can learn two more. Let's say distance is speed symbol is v, speed multiplied by time. If you draw a samosa like this, you can learn three different equations. Let's say if you hide d, you see that v and t side by side, so you can say that d equals to speed multiplied by time. Now if you want to find speed when distance and time are given, if you hide this, you see that this is distance over time, so you can write v equal to distance over time, d divided by t. Similarly, if distance and speed are given, you can hide t and calculate distance over speed. Okay. On the other hand, displacement has a similar equation. It's s equal to vt. In this case, v represents velocity, not speed. Okay, because it's vector quantity. So similarly, you can draw this one as s equal to vt, and you can calculate s or v or t from here. All right. A walked example. Let's say a person walks 3 meters to the east. So let me quickly draw a diagram. Let's say this side is east. That means this should be west. If this is north, this should be south. Okay. It walks 3 meters to the east. Let's say this is the original position. It walks 1, 2, 3 meters to the east. So from the original position, 3 meters. And walks 2 meters again to the west, backward to the west. So 3 meters this side, from the same position, 2 meters to this side. The total distance you have covered is 3 plus 2, 5 meters. Okay. On the other hand, if you are talking about displacement, you just covered 1 meter due east. If you look at the diagram, it's 3, then 2 minus, you are coming to this position. This is basically 1 meter. 1 meter from the original position due east. So your displacement is 1 meter due east. Okay. Another key point that you'll have to notice here is that distance is always positive, and it measures the total length of the path that someone has taken. All right. To recapitulate, distance is how much ground an object has covered in total. So the total path covered by an object. Okay. Even if you go a zigzag path, the total path that you have covered is the distance. And displacement is the straight line from the starting point to the ending. In other words, you can say shortest path covered between any 2 points. That's all. Thank you.